In example 1, we're finding an equation of a tangent line to the parabola y equals x squared at the point 1, 1. So in order to write the equation of the tangent line, we're going to have to find the slope of the tangent line at that point. And in order to find that slope, we're going to have to find the derivative of this function. This is the equation for finding the slope of the tangent line. This is also called the derivative. So you've got the limit as h approaches 0 of f of a plus h minus f of a all over h. We did this in pre-calculus, but this was an x. I'm going to use an x usually when I do it. The a just means that you're plugging in a number. So in this case, we have that 0.11. We would be plugging in a 1 for the a value. So let's go ahead and try this. So writing the equation of a tangent line, we first need to know how to write the equation of a line. So I need you to remember point-slope equation. This is just an equation from Algebra 1. We've got y minus a y value equals the slope times x minus an x value. Now the slope, in this case, because it's the tangent line, will be this limit equation. So this is the formal limit definition of a derivative, which is the slope of the tangent line. So our f of x is x squared, and we're going to go ahead and use the formula for x squared. So this was just the formula, and now I used x squared and the formula to create this. So when you see f of x plus h, that means you're taking f, which is x squared, and plugging in the input x plus h. So we have x plus h squared, minus the function with input x, so just x squared, all divided by h. Then on top, it looks like we need to FOIL our x plus h. So you can write this twice. And FOIL it. Notice this limit is in front of everything. It doesn't go away until you have plugged in 0 for your h's. Now looking at this, my x squareds cancel if we collect like terms. It also looks like on top we can factor out an h. Both terms in the numerator have an h left over, so we can factor out an h on top. Now that we have that h factored out on top, it cancels with the h in the denominator, and I can now plug in 0. I was not able to plug in 0 until just now. If I plugged in 0 here, it would be undefined. If I plug in 0 here, undefined, undefined, and now the h in the denominator is gone, so it won't be undefined if I plug in 0. So I don't need the limit anymore because I'm now evaluating it by plugging in 0, which just gives me 2x. So this is the formula for the slope. This is the formula for the slope. So we need to know an x value in order to know what the m actually is. And they gave us the 0.11 in the problem. So you're going to plug the x value from the ordered pair in for your x. So in this case, my slope is 2 times 1, which is 2. So I know the slope for my point-slope equation, and I also know a point. So this is my x1, this is my y1, and now m is 2. So we can go ahead and finish writing this equation of the line. So it'll be y minus 1 equals 2 times x minus 1. Technically, we're done. This is the equation of the line, but let's put it in slope-intercept form and get y by itself. So distribute that 2 and then add 1 to the other side. This way, it's easier to graph. So this is the equation of the tangent line at the point 1, 1. Example 2 is the exact same process. You're finding an equation of a tangent line. So you need to know how to write the equation of a line. And because it's tangent, you need to find the derivative using that limit definition of a derivative. Now, the only thing with this one is you've got a fraction, you've got a rational function, so you're going to need to get common denominators when you do the algebra here. So it's a little bit more complicated, but it's the exact same process, and we did do it last year. So go ahead, pause the video, and see if you can do this on your own. So we've got the function 3 over x at the point 3, 1. This is what you should have when you set up your function. You should have the limit as h approaches 0. You have x plus h in for your input variable x, minus the whole function with just x plugged in for x, all divided by h. Then what I did was I got common denominators. So you can't just put a plus h on here. You have to multiply. You can't just add something on top and on bottom. It does not keep your fraction balanced. So what you need to do is give this x to this fraction, give x plus h to that fraction. So that's what I'm doing here. I gave the first fraction an x, the second fraction an x plus h, and I've got a common denominator of x times x plus h. Then when you distribute your -3, make sure you include the negative. You end up getting 3x minus 3h on top, in which case these 3x's cancel out. So then you just have a -3h. So then on the bottom, you can go ahead and put a 1 on the bottom of your h over 1 and multiply by the reciprocal of this fraction so that you don't have a complex fraction. So that's what I did here. The 3x is canceled. I'm left with a -3h, and I multiplied by the reciprocal. Now we'll see that these h's cancel out, which is what I'm doing here. The h is gone. And now it is time to plug in the limit. So notice that limit stayed the whole time until right now when I'm ready to plug in 0 for my h. So we plug in 0 for the h, and I got this. So this is the formula for the slope. Formula for the slope. If I want to know what the slope actually is, I need to evaluate it at the point 3, 1. So that means I'm going to plug in my x equals 3. So if I plug in 3, I'm going to get -3 over 9, which is -1/3. So this is the slope of the tangent line, -1/3 at the point 3, 1. So they want the whole equation of the line. So plug in your 1, that's a minus. Plug in your 1, plug in your -1/3, and plug in your 3. Distribute your slope. And then add 1 to the other side. So that is the equation of the tangent line. Like I said, this is called the derivative of the function. So before this was just labeled with an m. Now they're showing you a new notation, which is f prime. So anytime you see f with a prime symbol like that, that means the derivative. And that means they're using this equation to find the slope. This is the equation that I will use most of the time. There is another way to find the derivative, and that is using this function right here. So this is just y minus the y value, and then divided by x minus the x value. So remember, the derivative is finding a slope. So this is just y2 minus y1 over x2 minus x1. Here the limit is approaching a, whereas the other one, the h is approaching 0. This is the equation of a tangent line. It's exactly what we have done already, where it's just y minus the y value equals the slope times x minus the x value. So when you see it written this way, just know it's the same thing we've done on the past few examples. Looking at the next example, we've got a polynomial, a quadratic, and they want us to find the equation of the tangent line at the point 3, -6. I would like us to try this new equation, but you also could do it with the limit as h approaches 0. I prefer the other equation, but we're going to try this one just in case we ever need it. Sometimes it's easier than the other equation, so Here the a value is my 3, so we're going to go ahead and use 3 for this. So this says f of x, so you're going to leave x alone. Minus, then you're going to plug in your a. You're going to plug in 3 for these. And then x minus a will be x minus 3. So go ahead and evaluate what this would be. So that's going to be 9 minus 24 plus 9. So we're getting negative 6 inside. So this is going to be plus 6, which you're going to go ahead and add, collect like terms, so add to your 9. Okay. So the problem is I can't plug in 3. I'm going to need to factor the top, so I'm looking for multiples of 15. That'll add up to negative 8. So if we use negative 3 and negative 5, we could factor it. Okay, now this x minus 3 cancels. So if I plug in 3, it's not going to give me 0 in the bottom anymore, which means now I can evaluate my limit and plug it in. So 3 minus 5, I get negative 2 for the slope. And so we want to write the entire equation of the line, which would be y minus the y value equals this slope times x minus the x value. Go ahead and distribute your 2, change that to positive 6, and then subtract 6 to the other side. So it looks like your 6's are canceling, and we're just going to get y equals negative 2x for the equation of the tangent line.